So there was a question on the form that I wrote out for the function that goes into the viscous stress. Okay, so I said that f of d, in order for it to satisfy objectivity, must have the form alpha naught, which can depend upon the principal invariance of d, plus alpha 1, also depending upon the principal invariance, times d, plus alpha 2 and so on. Okay, that's a polynomial expansion. The reason, and the question was why this particular dependence upon the principal invariance, right? So if these are these are the principal invariants. So why this dependence? Why do they have to depend upon them? Well, the reason is that if they did not depend upon the principal invariance but depended upon some other functions of d, then you have the possibility that when you apply rigid motions upon the current configuration, those functions will not be constant. Okay? However, having chosen these to be the principal invariants of d, what we also have is that the principal invariants of q d q transpose are the principal invariants of d. Of course, I'm abusing notation by writing q d q transpose in a subscript, but I think you understand what I mean here. Okay? The whole point is that the principal invariance of d are invariant precisely under rigid motions of any kind, right? Principal invariants of d are invariant for all q belonging to SO3. Right? Otherwise, we would have a situation where the alphas would change under rigid motions, right? And you would have coefficients, scalar coefficients in your constitutive relation for the viscous stress that would change with rigid motions. Okay?